Earlier, we have discussed about the basic terms of mirrors which are involved whenever the light is incident on the mirrors, and as well as also we know that the sign convention means when the incident light in the direction of the incident light, if the values are taken according to the sign convention, all the values must measure from the pole. Then as well as that whenever the values which are taking, the distances which are taking from the pole to the in the direction of the incident ray taken as positive, otherwise if the opposite direction taken as negative, and in case of if the above the principal axis the distance is taken as positive and below the principal axis taken as a negative. Next we are going to know that what is the relation between the focal length and radius of curvature. Means here when the concave mirror has taken, this is the concave mirror we are taking, that this is concave mirror, consider it's a M and be the concave mirror, and as well as this one is the principal axis, this one is pole P, and the center of the curvature means the center is C. When the light ray is incident on the mirror, on concave mirror, means this is the incident ray, and it is reflected, converged at point, this is called as a principal focus F, principal focus F, which is the perpendicular line, means it is drawn from the principal axis to the center from point M. The incident ray is making an angle theta with the incident ray. The center, the incident ray is making an angle with the center is a theta, and as well as whenever we taking that, we know that from P we are drawing a perpendicular line from the point M to the principal axis. Consider it's a either D, consider sum of D, whatever did D. So here it is that whenever we are taking the values of here, the P is the pole, F is the principal focus, C is the center of curvature, and at the same time M be the point where the incident ray, this is a reflected ray, and as also we know that the incident ray is this is I, and which is the angle of reflection is also theta, the angle of reflection also theta, because according to the laws of reflection, the angle of incidence which is equal to the angle of reflection. So here is that we are taking that here the P is the pole, and as well as C is center of curvature, and as well as here we are taking an incident ray making theta angle with C, means center of curvature, it is called as C, and it is making an angle incident ray, and also reflect theta is also same as theta is also reflected ray. We can say that this will be also theta, but this will be the 2 theta because of here is the angle, then we can say that theta plus theta is a 2 theta, so that's why this angle becomes a 2 theta, means angle MCP is equal to theta. MCP, the angle MCP is equal to theta, as well as angle MFP is a 2 theta. Angle MFP is a 2 theta. Here is that angle MCP is equal to theta, angle MFP is equal to 2 theta. Here is that whenever the incident angle is incident on the point M and is reflected and incident on the principal axis at a point, then that is called as principal focus. and the angle made with the center of curvature is theta. The incident ray angle made with the center of curvature is theta, and also reflected angle is also same according to the laws of reflection. So here is that is theta, so that's why at the point of MCP is becomes theta, as well as whenever it is theta and it is reflected angle is also theta. So total by at a point F, the angle made MFP is equal to 2 theta. Then so here is that MCP is equal to theta and angle MFP is equal to 2 theta. Then next, according to from the diagram, we know that a C triangle from triangle CMD from the triangle CMD, that is tan theta, because of it is tangent to that, so that's why we are taking the tan theta. Then CMD, triangle CMD is equal to, we know that what is tan theta? Tan theta is equal to opposite by adjacent. What is opposite in this? MD by what is adjacent? Here is that CD. Here is the MD by CD. Then next, according to from triangle FMD, from the FMD we have the then again tan 2 theta. Here 2 theta is there, so that's why we are taking tan 2 theta is equal to MFD. Opposite is equal to MD by adjacent is a FD. So from that case we can write that the angles are very small. The angles are very small, so that's why we are writing that tan theta is equal to, is similarly equal to, theta angle is very small, theta is a very small. So tan theta is equal to, similarly equal to theta, tan 2 theta is equal to, similarly is equal to 2 theta. Means here the theta is angle is very small, which is making an angle with the center is very small. So that's why we are drawing perpendicular on the from the center of curvature. So here is the theta angle is very small whenever the incident ray is incident at a point M. Then also, so here it is we are writing that the tan theta is similarly equal to theta and tan 2 theta is also equal to 2 theta. So here we are substituting in this case, then theta is equal to MD by CD, that is equal to, and again 2 theta is equal to MD by FD. So from this we know that theta is equal to MD by CD. We are substituting in this 2 theta is equal to MD by FD. Instead of theta we are writing MD by CD. Means consider it's equation number 1, consider it's equation number 2. Substituting equation 1 in equation 2, then we can get 2 into theta is equal to MD by CD, that is equal to MD by FD. MD get cancelled. All we know that from CD means the distance is nothing but the distance is very small, so we will consider P is equal to D. So that's why from the PD also CP also both are the same. So here the CD is equal to the radius of curvature, so that's why that is R, and here is FD is that is nothing but a focal length. The distance from the pole to the principal focus is called focal length, and the distance between the pole to the center of curvature C is called radius of curvature. So here is that we are writing that 2 by what is CD? CD is equal to R, that is equal to 1 by FD means the distance between the pole to the principal focus is F. If we cross multiply both sides, then we can get F is equal to R by 2. That means to say R is equal to 2F. This is the relation between the radius of curvature to the focal length, means of the radius of curvature which is equal to the double of its focal length. That means to say the focal length which is equal to half of its radius of curvature. This is about the relation between the radius of curvature and focal length. Once again, when the relation between the focal length and radius of curvature is, first of all we are taking the concave mirror, it's a converging. Then when the incident light is incidented at a point M, a incident ray is incidented at a point M, and it is reflected, means converged into at a point F on the principal axis, which is making an angle with the center is theta, that is incident angle, and this will be the reflected angle, means here is the reflected angle and this is the incident angle, which is both are according to the law of reflection, the angle of incidence which is equal to angle of reflection. So here it is that the I is equal to R, means angle I is equal to angle R. So from that case we can write that a point C, at point C the angle made is according to the MCP, the angle MCP is equal to theta, and also the MFP is equal to 2 theta. We know that angle MFP because of here is that angle of incidence is theta and angle of reflection is theta. We know that the angle of incidence is theta, then it will become, so according to this is also theta, and according to the similar triangles based on this, then theta and theta means theta plus theta, here is that angle, this angle becomes 2 theta. So here is that the angle MFP is equal to 2 theta. Then from the triangle CMD, D means this is the imaginary perpendicular line we draw near to the, because of it is a curved path, it is a curved mirror, curved, so that's why we are drawing that perpendicular line. So here is that. Next, here the angle MFP is equal to 2 theta. Then from the triangle CMD, CMD means from CMD is angle theta, so that's why it is tangentially, so that's why tan theta is equal to MD by CD, opposite by adjacent. Then from the FMD, from FMD we are taking that the tan 2 theta, the tan 2 theta is equal to opposite MD by adjacent FD, so MD by FD. From this case consider it's A and B, then angle theta is very small, the reflected angle or incident angle is very small, so that's why the tan theta becomes nearly equal to theta. We will consider that. Then tan 2 theta is similarly equal to 2 theta. Then from A and B these two equations becomes theta is equal to MD by CD and 2 theta is equal to MD by FD. From that case consider it's a C and it's a D, substituting equation C means theta is equal to MD by CD in equation 2 theta is equal to MD by CD, means instead of theta we are substituting the value of MD by CD. So here is that substituting C in equation D. So 2 into MD by CD is equal to MD by FD. MD get cancelled, then we can get 2 into 1 by CD is equal to 1 by FD. From the diagram we know that what is CD? C to D means the distance from the pole to the center of curvature will becomes the radius of curvature, so that is R. And as well as the distance from the pole to the principal focus, that is focal length, is becomes F, so that's why CD is equal to R and FD is equal to F. So we are substituting the values, you can get this one equation, R is equal to 2F. So here the F we can get that whenever CD is equal to R and FD is equal to F substituted, then we can get 2 by R is equal to 1 by F, means CD is equal to R and FD is equal to F. By the cross multiplication we can get that F is equal to R by 2. F is equal to R by 2 means the focal length of a concave mirror, means the focal length of a concave mirror which is equal to the focal length of a concave mirror, the focal length of a concave mirror is equal to half of its radius. Half of its radius means which is having the radius of a mirror is R, so that's why the focal length depends on this radius of the concave mirror. So here it is that from the equation we can write that R is equal to 2 2f also means in this case the radius of a concave mirror which is equal to double of its focal length. The radius of the concave mirror means the radius of concave mirror is equal to double of its focal length. Double of its focal length. Yeah. This is about the relation between the focal length and radius of curvature. We should know that by taking the convex mirror also we can get the same thing. Means by the diagram only changes, but everything will be remain same. So also we can say that always according to the spherical mirror, either concave or convex, the focal length which is equal to r by 2 means the focal length of a concave mirror is equal to the half of its radius, and as well as we can say the radius of a concave mirror or convex mirror which is equal to the double of its focal length of a convex or a concave mirror.